Hello everyone. Today we are going to start the last portion of the syllabus, fifth module. It is centrifugal pumps. It's interesting, simple. Theory involved is quite simple. You can reproduce, and even conceptual part as far as mathematics is concerned is also not so intense. So by definition, what is pump? Pump is a mechanical device which converts mechanical energy into hydraulic energy, especially hydraulic energy as a pressure energy. And then pumps are used for lifting the fluids. Means the potential energy of the fluids is increased. Now, broadly, the pumps are classified as rotodynamic pumps and positive displacement pumps. If you have heard reciprocating pumps, etc., those are positive displacement pumps where a lot of movement of mechanical parts happens and then efficiencies are less. The most efficient pumps are rotodynamic pumps, especially we are going to study centrifugal pumps. So types of pumps, if you look at here, we have positive displacement pumps. There you got so many types. Jet pumps are there, and then rotodynamics pumps, which are generally referred to as turbo machines by mechanical engineers. We are going to discuss especially this centrifugal pump, which has got axial inflow and radial outflow. So what is the basic idea behind centrifugal pump? If you look at here, there is a container with liquid. It is stationary, not moving, so liquid is having a horizontal top surface. Here if you give a rotation for the container along with the fluid inside, it is obvious that the fluid surface gets depressed at the center and then it rises at the edges. So similar rotational effort is imparted to the liquid by impellers in centrifugal pump. What is impeller? So this particular part is known as impeller. We are going to see that in detail in the next slide. So how the pressure is developed by centrifugal pump? If you look at this, centrifugal pumps accelerate the liquids. Now it is a rotation. So the maximum velocity reached is the velocity at the periphery of the impeller. So when it is rotating, you know that if you are nearer to the center, velocity gained is less. If you are farther away from the center, then the velocity reached will be more and more. The kinetic energy is converted into potential energy as the fluid leaves the pump. The potential energy developed is approximately equal to velocity head at the periphery of the impeller. So h, the head reached, will be equal to v squared by 2g. V is nothing but the velocity gained at the periphery. So final statement, a given pump with a given diameter and speed will raise the fluid to a certain height regardless of fluid density. So here there is a good view of a centrifugal pump. They are also referred to as radial pumps, because water moves radially outside. It enters at the center and then it moves outside like that radially. That's why it is called radial flow pump or radial pumps. It has broad range of applicable flows and heads, means they can be designed for more discharge, less discharge, etc. It can be designed for less head or more head. So there is a lot of flexibility. Now higher heads can be achieved by increasing diameter, that is this diameter, or the rotational speed of the impeller. So what are the main parts? If you look at, the water enters at this particular point, which is known as suction eye or eye of the impeller. This rotating part inside, which is colorful over here, is an impeller. The blue one is known as scroll casing or volute chamber. This impeller is rotated by electrical motor. So when you supply electrical energy, obviously this rotates, and in turn impeller rotates. Impeller will be able to suck the fluid from the center and then give its energy by rotation, and this will be pushed up the delivery pipe.